Hey everyone, welcome to the MacMillan Space Centre. I'm Michael, the program coordinator here, back with another live Q&A. Glad you could find us as we switch up our schedule. But we've got some really exciting news to talk to you about today. So if you're able to like and subscribe, you can catch up with all of our breaking news as we're going to be going live sometimes randomly as things happen in the universe. So make sure you like and subscribe so you can get those notifications. And of course, this week, we're going to be talking about something super exciting, aren't we, Rachel?
Yes, I'm very excited. Potential aliens, maybe, in our solar system. We'll see.
Awesome. Yeah. So we're going to be talking about this discovery that was made just on the weekend. We had planned for something else this Thursday, but we're like, you know what? Let's dedicate this Thursday session to this news because it's just so big. So everyone out there watching, make sure to put your comments and your questions in the YouTube chat. And we'll get to all of those and shout out to everyone watching from all across the Canada, actually, from Mission, BC. We got a grade 3-4 class from Surrey. Wow, awesome. From Yaletown, and we also have Hannah and Armony from Windsor, Ontario. So glad to have everyone with us. And let's get to a little presentation, Rachel, on what this discovery was, and then we'll get to everyone's questions.
Sounds good. Takes a little while for the screen share to kick in, as always. So hopefully you're able to see a slide that says, in our backyard, biosignatures found on Venus.
You're good to go.
Thank you. Alrighty, so we're talking about the search for extraterrestrial life. So life that exists not here on Earth, but somewhere else in our solar system, or maybe even outside of our solar system. And how we look for extraterrestrial life is we look for signature markers, and we call these markers for life biosignatures. And it could be really anything. It could be a substance like an element or a molecule, or it could be a phenomenon or an event. And it's just something that gives scientists an idea or an indication that there is past or present life wherever we detect these markers. Now, the first experiments that were designed to look for these biosignatures were actually the Viking missions to Mars in the 70s. And you can see on the right here, we have Carl Sagan, who was one of the science advisors for those missions. So it's exciting to see where we've come from the Viking missions in the 70s all the way until now. Now, I thought I'd start off with an example of a biosignature, something that's really familiar. We all know oxygen, we use it to breathe and live. And on Earth, the majority of life is centered around oxygen. And that's because it's a byproduct of photosynthesis produced by trees, plants, other forms of life. And it's a great biosignature. And the reason is because it's very easily detectable. So when astronomers are looking for signs of extraterrestrial life or these signs of biosignatures, we do something kind of like scanning a barcode. We scan an atmospheric barcode, and we're looking for these particular signatures. And so if you take a look on the left here, we have the atmospheric barcode for oxygen, and you'll see that there's multiple bands, and it's also over a wide wavelength range. So that makes it a really good biosignature because it's readily detectable. Now, because oxygen disappears over time, if we find a lot of oxygen, like if an alien species came and scanned Earth, then we would know that there should be something on this planet outputting oxygen, because if it's disappearing over time, there has to be something continually replacing the oxygen supply. But there is a problem that all of these markers or all of these biosignatures face, and that's something called false positives. So for each biosignature, there is some sort of non-biological process or a process that isn't done by life that could produce the same kind of features or mimic the features of these biosignatures. Now, specifically for oxygen, we know of several different mechanisms that can generate a lot of oxygen without life being present. So that's one example of a false positive that we might detect from a biosignature. All right, but enough about oxygen. Let's move on to phosphine, because this is what all the excitement is geared around. So this is another great biosignature, and we can apply what we learned about oxygen as a biosignature to this phosphine gas. Now, phosphine is a pyramid-shaped molecule. you can see one phosphorus atom on top in orange and a base that's formed of 3 hydrogen atoms in gray. Now, it's the simplest gas that has phosphorus in it. You can think of it as the phosphorus equivalent of something like ammonia for nitrogen, methane for carbon, and water for oxygen. Now, for most people, this is probably the first time that you've even heard of phosphine. And that's because on Earth, it actually is quite rare. It's either made naturally by life on Earth or artificially by humans in labs, and often for not so great reasons. But interestingly enough, phosphine is actually toxic to aerobic life. And examples of aerobic life are you, me, your neighbor's dog, your cat, life that needs oxygen to breathe now and survive. Now, for anaerobic life that doesn't need oxygen, it actually has no issues with phosphine. So it isn't toxic to life that doesn't require oxygen. Now, to make phosphine, it's extremely hard to make, and it's only spontaneously made in extreme environments. And one example of an extreme environment where phosphine is made is in the extremely high temperatures and pressures on Jupiter and Saturn, our 2 gas giants in our solar system. But in Venus has a greenhouse gas atmosphere. It's full of oxygen-containing chemicals, things like carbon dioxide, which normally would soak up all of the phosphorus and phosphine. So if it soaks up all the phosphorus, we can't make phosphine. So for the molecule to be present at any level whatsoever, let alone at the amount that we're seeing now or the concentrations that we're seeing now, it definitely becomes a head scratcher for researchers all around the world as to why it's there. Now, there are lots of molecules that are associated with life. We've talked about 2 of them. We talked about oxygen and phosphine, but others could be things like methane and water. So if we detect these molecules, it could indicate the presence of life, or it could indicate a non-biological process or mechanism that gives us a false positive. And we talked about this when we talked about oxygen being a biosignature. But what's exciting about phosphine, and has researchers all over the world very excited, is that phosphine doesn't have any currently known production routes in Venus's atmosphere. And actually, most of the paper announcing the discovery was actually dedicated to analyzing all the possible different methods that could potentially explain the production of phosphine or the presence of phosphine. But they found that even their best routes that they thought could explain the phosphine production actually were off by a factor of 10,000. So in simple terms, that means to the best of our knowledge, we should only detect phosphine at this concentration if there is life. And we have no other way of explaining it currently without the presence of life. So that's very interesting, and that's why everyone is all up in arms about it. So how did they make the detection? Well, researchers used the James Clerk Maxwell Telescope in Hawaii, and then later followed it up with 45 telescopes from the more powerful Atacama Large Millimeter Array in Chile. And so from the combined spectral detections of these observatories, researchers have found no other plausible reason or identification for that spectral barcode that they're seeing besides phosphine. So they're pretty sure what they detected is phosphine, and they're not exactly sure how it arrived there. But researchers are erring on the side of caution and are encouraging scientists to try and come up with a possible alternative explanation other than aliens being on Venus. Now, if you take a look at Venus, it looks like an absolutely terrible planet to live on. The Soviet-era Russians sent a series of space probes to Venus, all of which could only survive for a short period on the surface because of the extreme conditions. It's extremely hot. As soon as the landers landed, they would melt because it reaches temperatures around 470 degrees Celsius. And when I say that they were short-lived when they landed, I mean it's anywhere from 20 minutes to 2 hours that they were able to survive on this incredibly hot planet. But that's on the surface of Venus, and where we detected phosphine was in the atmosphere of Venus, which is 50 kilometers up from the surface. Now here, the atmosphere in Venus is actually pretty similar to Earth's. It has the same kind of atmospheric pressure. It has temperatures ranging from 0 to 50 degrees Celsius, and actually a pretty similar gravity here. So even in our own atmosphere, we've detected microbes floating about. But any microbes that we could find on Venus will probably be very different from the microbes on Earth because Venus's atmosphere is very acidic. So if there are microbes, they've probably adapted to their environment, and that's a hyperacidic atmospheric environment. But to find out for sure, we'll need to send a mission into the atmosphere to look for life. Now, there are several proposals on the table, the closest launch being potentially as soon as 2023. So in the next 3 years, we might be able to send a probe and go and try and confirm the presence of phosphine gas. And what's cool is, as luck would have it, a joint mission with 2 spacecraft, one from the European Space Agency and the other from the Japan Aerospace Exploration Agency, is actually about to fly by Venus just shy of a month away. It was launched in 2018, and Bepi Colombo is on its way to Mercury to begin orbiting the planet at around 2025. And it's meant to study the planet from unique vantage points or unique perspectives. So I said that it was 2, one of them from the European. Now the question is, well, why is it flying past Venus if it's on its way to Mercury? Well, it'll actually use 2020 this year, and another is on August 11th of next year, 2021. Now, the 2 teams had already planned to observe Venus during their flybys, but now because of the detection of phosphine from telescopes on Earth, they're planning to use both flybys to look for phosphine. Now, the European Space Agency scientist Johannes Benkoff says that we could possibly detect phosphine, but they're not exactly sure if their instrument is sensitive enough to detect it in the atmosphere. Now, the instrument on the European side of the mission is called MERTIS, and it's designed to study the composition of Mercury's surface. But the team is hopeful that they can also use it to study the atmospheric composition of Venus during both of these flybys. So on the first flyby, which is coming up in less than a month, the spacecraft will come pretty far out, but there is still a chance that there could be a detection. They would just have to be very, very, very lucky. But on the second flyby, it's a little bit more promising because not only do they have more time to prepare, they also are flying by even closer at around 550 kilometers away. So if a detection can be made, it would be fantastic for scientists because it would be an independent verification or an independent measurement of the presence of phosphine in the atmosphere, in addition to the detections and the measurements from telescopes on Earth. So it would be a totally independent confirmation of detection of phosphine, which is very exciting and very fortuitous that we are sending a probe and it's on its way there. Because it often comes up in the 2 ideas that are related to the likelihood of finding life out there. So we have this abstract math equation called the Drake equation that was developed by Frank Drake as an estimate for the potential number of intelligent alien civilizations in our galaxy. And it involves a whole bunch of different numbers and different factors, things like this R here is the average rate of star formation. We also have an Fi in the middle, which is the fraction of planets with life that develops eventually into intelligent life. And we have things like the expected lifetime of an intelligent civilization that can communicate and is able to send out signals into space. And all of these numbers are really, really hard to quantify. So really, it's just kind of just a way of stimulating curiosity about the universe and what's in it. Now, related to this idea is something called the Fermi paradox, and that was proposed by a physicist, Enrico Fermi, who highlights this apparent contradiction between the lack of evidence for extraterrestrial civilization and optimistic estimates for the probability of their existence, estimates like the Drake equation. So it relies on 2 ideas. The first is that given the huge number of stars in the observable universe, even if intelligent life was only on a tiny, tiny fraction of those planets around those stars, there might still be a large amount of civilizations out there. So that first one is based on the fact that there is a lot of stuff in our universe. Now, the second one is that it seems probable that at least some civilizations would be technologically advanced, such that they would seek out new resources in space, like we are doing with asteroid mining, exploring and colonizing nearby star systems, which we hope to do, and send out signals into space. So if these civilizations do exist, there is a chance that they are smart enough and intelligent enough to have the technology to contact us and send out signals into space, which we would detect. So scientists in and out of the community for the search for extraterrestrial life and extraterrestrial intelligence have come up with other arguments to try to explain away this paradox. And so in the 1980s, there were dozens of papers published to address this apparent paradox. And they considered a lot of different arguments, from technical arguments and sociological arguments, for why aliens aren't hanging out nearby. And some even insisted that there isn't any paradox at all because there aren't any extraterrestrials out there, or they've visited Earth already before humans existed. Now, I'm personally extremely excited about this announcement because it's so close to home. So when we're talking about the search for extraterrestrial intelligence or the search for aliens, we're often talking about it in the context of planets and exosystems. So these planets and systems of planets that exist outside of our own solar system. In other words, they're very, very far away. But Venus is just one planet away. So it's almost like it's in our own backyard that we're looking for life and looking elsewhere outside of our solar system for life all this time. So with this detection being so close to us, it means that life could be way more abundant than we once thought. And that gives me a renewed sense of hope for looking for extraterrestrial intelligence. All right, so that brings me to the end. So I'm actually going to kick off the Q&A. Michael, I'm going to ask you a question as I stop my screen share. And my question is, it was asked to me by a journalist yesterday, and she asked, what do you think the impact of this discovery is on the average person?
Oh, wow. Well, I mean, I guess we could throw that the question out to the people watching
For
here
sure.
today. Well, here's, and I've been poring over lots of articles, going through space Twitter, which has just been blowing up since Monday. And here's sort of like what I've found, so for like the really hardcore space astronomers on Twitter, they kind of have like this knee-jerk reaction, which is, cautious optimism, and always have to be like, probably not aliens. And there is actually even one astronomer, she actually has in her bio, almost never aliens. And then she tweeted out, okay, maybe aliens this time, because that's kind of like what we're talking about. But you do have to clarify, Rachel, like we did not detect life. What we detected was this molecule, or I guess like this phosphine
Biosignature. Yeah.
biosignature, yeah, which we don't have any explanation that it could be formed besides life. So
Exactly. Yeah. So yeah, we've tried to come up with any way that we can explain away the presence of phosphine gas without aliens, but we haven't come up with anything so far.
Yeah.
But scientists are still working away at it, and hopefully data from the upcoming spacecraft that's going to do a flyby will give us a little bit more information.
Yeah, so I think like I take that sort of approach, and we take a question from Joy's child who asked the question about like the alien that was found there, and we do have to clarify that it's not an alien, but now we're kind of like a little bit more optimistic than we were before now, right? So I think that is where the impact is that the knee-jerk reaction for I think the public is it aliens? Is it aliens? And now we can actually say, okay, maybe aliens, but we need more evidence. So you kind of described like we need more data. We need the spacecraft that's flying by. We need to send probably a balloon, floating into the atmosphere of Venus so that we can really get that detection. And in thinking about, how exciting that is, because I started hearing scientists talk about how there is microbial life floating in our clouds on our planet, but they don't last that long because the clouds, they move around and sometimes they dissipate. But on Venus, the clouds are there all the time. So they would have time to maybe like develop, a much more richer ecosystem, which I found kind of fascinating. I never even thought about that there would be life floating around in the clouds above us. And then I went digging a little bit more. So I started looking at like, okay, how did we discover phosphine? And so originally it was this mixture of phosphorus and potash, which is sort of like this thing that is used in some food. So I went to my chef friend and I was like, hey, have you ever used potash before in any of your cooking? He's like, oh no, it's used in a lot of like German foods. And then I was like looking and it was like, well, phosphine, if you were to smell it, it would smell like garlic and rotting fish. And I was like, oh, that kind of sticky. But then he was like, no, that sounds like a perfect sauce. He's like, that's like garlic and sort of like rotting fish that like kind of makes for a good sauce base. So maybe in the atmosphere of Venus is like actually like this rich sort of like saucy material that life is sort of living in. See, so
The
you
secret
asked like
sauce.
you asked like what the impact is, and that's where the impact is that you can sort of like ask this really exciting question that kind of leads you down this rabbit hole of all these like potential exciting stuff. The other thing that I want to say is that you did talk about trees, and sort of like where oxygen comes from and sort of the potential for trees connecting us to life. And I want to throw it out to everyone watching because we have a really special event happening next Tuesday. I'm not going to tell you what it is. Hopefully somebody in the chat can let us know what is happening next Tuesday. It's connected to trees kind of, but hopefully somebody gets to the chat, then I'll reveal at the end. But let's go to some questions. And of course, we had the question about the actual alien life from the 7-year-old son. How abundant do you think this is? Is that just sort of like speculations?
So
The phosphine detection, yeah.
Right. So the concentration of phosphine detected in Venus's atmosphere was in the parts per billion. It's 20 parts per billion. So for every billion particles they found of other particles, they found 20 of them being phosphine. But on places like Jupiter and Saturn, where phosphine gas is being produced naturally because of the high temperatures and pressures, and it just has the right kind of conditions for it, it's in the parts per million. I think it's somewhere between 5 and 15 parts per million. So it's a lot more on Jupiter and Saturn, but then you keep in mind that they just have the perfect environment for it. So for phosphine gas to be detected in any sort of concentration at any level, we don't expect it on Venus because we expect that the stuff in the atmosphere that's already there is going to soak up the phosphorus. So there's no phosphorus left to make phosphine gas.
Yeah. And what's really interesting when you look at all of the missions that we're sending, and Venus kind of gets left out a lot, but that didn't used to be the case. Like back in like the 1950s, I remember Carl Sagan, you had his picture up very early on. Like he, thought that there might be life in this, and Venus became like a really interesting place that we thought could find life. And so it's kind of nice now that to realize, actually, we just have to think of it a little bit differently. It's life as we don't know it. And I think that's one of the key takeaways from this discovery is that if we do find life in the clouds of Venus, it's going to be very different than any of the life that we have seen so far. And I'm kind of glad to see Venus back in the news. It's a wonderful, beautiful star up there in the sky. Great to look at through a telescope, really close to us, so we could send lots of missions there. Hopefully
and it won't
soon.
take decades to get
Exactly. So great question from Ruth, who's the teacher for a grade 3-4 class, wondering how long Rachel has been an astronomer, and have you always wanted to be an astronomer, Rachel?
So I started working at the Space Center as an astronomer actually just last year in mid-July is when I started. And I'm going to answer yes, I've always wanted to be an astronomer, but in kind of different ways. Being an astronomer, there's a whole bunch of different jobs that you can do. And for me, I'm in science communication working at the Space Center. So that involves things like teaching the public and educating the public on things like new detections and new discoveries. But also, I really liked setting up a telescope and going outside and looking at the night sky and looking at all the different objects in it. And then as I got older, I started liking the math side a little bit more. So yes, I did always want to be an astronomer, but I went through different phases of what kind of astronomer I wanted to be.
Yeah, there's definitely different kinds out there. I do remember you gave a talk about that, and that was really fun. Question from Joy, I guess through the 7-year-old, which is, of course, a question when it comes to trying to find life in this dimension, but what about life in another dimension? What are your thoughts on sort of like interdimensional life, Rachel?
That's interesting. I think the first thing we have to figure out is how do we access the other dimensions. So we live in 4 dimensions. We have 3 that give you spatial positions, and we have 1 that gives you time. And if we were to have other dimensions, I don't really know how we would go about accessing them, because it's already hard for us to picture things in 4 dimensions, let alone adding a 5th or a 6th or up to 11 dimensions. But like, as you said, there are many different forms of potential life. We know that we're looking for carbon-based life because we are carbon-based life, and that's all we know. But there could be things like methane-based life. And that was one of the speculations of Titan, because Titan has these liquid methane lakes. And so if there was methane-based life, it would thrive on places like Titan. So, we're really expanding our horizons in terms of what exactly we're looking for and what life looks like.
Yeah. When it comes to thinking about interdimensional life, of course, there's the classic story Flatland. Have you ever read Flatland, Rachel?
No.
So Flatland is it's a very pretty old story, but it's basically about a race that lives in a 2-dimensional world. So they just go here and they bump into each other, and then a 3-dimensional being comes in, and they're observing the 2-dimensional world. But of course the people in the 2-dimensional world can't see that 3-dimensional being up there, but even though the 3-dimensional being could like swoop down and like pick somebody up from the 2-dimensional world, but that other person in the 2-dimensional world would have no idea what just happened to that other person. They went up this way, but there is no up, right, to the person in the 2-dimensional world. And that's kind of like us, right? Like, we only have our senses for the dimension that we live in. We would have to come up with different kinds of detection methods to understand what could be living in a different dimension. It's an interesting philosophical thought, good for stories and
brain
theories.
breaking also.
Brain breaking, yeah. Let's go to another question from Adea Tech. I'm not sure if that's the name or just like your handle on YouTube, but Adea asks, if they detect microbes on Venus, will they try and bring some back, or is it too dangerous because of diseases and things like that and getting contaminated?
Interesting. Yeah, that's definitely something that is part of the discussion about going to other worlds and possibly us bringing contaminants to those worlds and also bringing contaminants back. And I think that if we did find life or did find microbes on Venus, I think that we would bring samples back, because I think that sort of information is absolutely invaluable. And I'm sure that we would take the necessary steps, to have self-contained units, make sure that they're isolating, much like when astronauts go up to the ISS, they also do that. They quarantine themselves before going up. I'm sure that if we did the same thing, we would be able to learn a lot from these samples of life.
Yeah. And shout out to Keith, who wrote the author of that sci-fi story, Flatland, by Edwin A. Abbott. So everyone out there, I'm sure every library has got a copy of Edwin A. Abbott. At the internet too. It's probably public domain at this point. So nobody got my teaser about what is happening on Tuesday, but we are going to be live on Tuesday at 2 p.m. to celebrate what, Rachel?
The September equinox.
September equinox, yeah. And of course, that's connected to trees, because that's exactly like what we're focused on. We are going to be bringing in some experts from the UBC Indigenous Initiatives Forestry Program, and we're going to be talking about different perspectives about the importance of trees on our planet. I find this really fascinating, and we probably won't have enough time on Tuesday, but I think we'll kind of keep digging into this question, like, how essential are trees to life on this planet? And then thinking about, could there be trees on other planets that have life? Of course, maybe not Venus, but, perhaps one of these exoplanets that does have a stable atmosphere. What would those trees be like? I'm really fascinated by that. But of course, we're going to have to get it out of our space bubble and talk to somebody else in another the discipline. So we're going to be bringing in some of these different perspectives. So that's going to be on Tuesday at 2 p.m. Of course, not our regular time slot, but all of you know by now, you need to like and subscribe so you know when we're going to be back live. And then you'll also get notifications for our special Cosmic Night. So our Cosmic Nights, if you've not been to one before, that's when we get to deep dive. That's usually 7 p.m. on Wednesdays, sometimes Thursdays. We're going to be bringing a special guest. And on the 23rd, we are going to be talking with Dr. Michelle Kunimoto, who has actually discovered exoplanets, not just one, not just two, not just three. I think her current count is like up to 23 discoveries. But the really cool thing that she's going to be talking about is how you don't have to go to school to discover an exoplanet. Like, what? How do you do that? Well, got to come in and find out Cosmic Nights, exoplanets. Rachel and I will be there. It's a full hour program, and you get to join us in Zoom, ask tons of questions. We've got fun games and polls. So make sure you come to that. And we're also going to be doing in-person experiences. I saw a few people on the chat that are going to be visiting us on this Saturday for our Extremophiles program. Very timely, actually, that we have an Extremophiles program on Saturday. It's sold out, but we will be doing more of them. So make sure to check our website for those in-person experiences. That's like a hands-on workshop where our interpreters are going to be leading you through some really fun activities. So lots of fun stuff in store for us as we get going into the school year. Shout out to everyone in school right now. Maybe you're homeschooling right now. Make sure to get your parents to like us, subscribe so you can join us on these programs. Thank you so much, everyone. We will see you next time.